All right, Chapter 4, Section 5 is solving polynomial equations. We are going to be using everything we learned just recently with factoring, and now we're actually going to solve. Okay? You should have noticed as we were doing the quiz and all those assignments, they gave you something that looked like this. Right? And they said factor. Okay? There's no equal sign, right? So there's nothing to solve here. Okay? When we're solving, we're finding the solutions. We're finding the zeros. Now it's equal. Now we're getting everything equal to 0, and we're going to solve just like we were solving with our quadratics. Okay? Now our quadratics had how many solutions? 2. Okay? How many solutions is a cubic going to have?
3.
What about a quartic?
4.
4. Okay? The degree of your polynomial is how many solutions it's going to have. Okay? When I ask you for a 0, what is a 0? What are we actually finding? Where it crosses the x-axis. Okay? So this is all the same as when we did quadratics. We just have higher degree polynomials now. Okay? You solve this the same way you factored just yesterday on our quiz. What do I have to do to factor this?
Multiply 5 and take out what you can.
See if there's anything you can take out of all of it, right? Which would be a 5x. So I take out my 5x. I'm left with x squared minus 8x. Uh-oh. Shut that off, please.
14, 20 something. 16.
And it's still equal to 0. Okay, just like we did or have been doing with factoring, you want to get it down as far as possible. Okay, so now how do I factor this set of parentheses?
What times what?
What multiplies to 16
And adds to
and adds to negative 8?
negative 4.
Negative 4 and negative 4. So I have x minus 4, x minus 4. Do I still need this 5x?
Yeah.
Yes. Equals 0. Is it completely factored now?
Yep.
Yes. Now, if you had to factor it, would it be okay if you put x minus 4 squared instead of writing it twice?
Sure.
Yeah. You could definitely do that if you really wanted to. No need to, though. Okay, just leave it as is right now. Thanks, Nate. Okay, leave it like this for now. Because we're just trying to find the 0. So all you need to do is take each of these and set it equal to 0. So when I take 5x equal to 0, what do I get for x? 0 divided by 5 is 0. When I take x minus 4 equal to 0, I get 4. Okay, now I could do this again, but I'm just going to get 4 again, right? Okay, there's no reason, bless you, there's no reason to write the same number twice. Are there still 3 solutions? Yes, but it only crosses or touches the x-axis twice because 2 of those numbers were the same thing. Does that make sense?
Yeah.
So what this is telling me is instead of crossing the x-axis 3 times, it's going to cross it once, but then another place it's only going to touch it. And I'll show you why here in a second, just based on what we know about cubics. Okay, we'll talk about that. Actually, that's not on the next problem. Okay. When I get 2 things that are the same, if I were to graph this, I know it's going to touch at positive 4, but it's not going to cross, because if it were going to cross, then it would have to come back up because it's a cubic, right? Okay. Then it would cross how many times? 3. But we only got how many answers? 2. So I know at one of those points it is not crossing, It is just touching and then going back up. Does that make sense? Okay. You'll do some graphing. Well, you won't graph. You'll select the correct graph on your assignments, and hopefully you catch on to that pattern. You might have to look at that sheet that I gave you and look at the end behavior of your graph so that you can determine exactly what would be happening. Yes, Peyton? It only crosses in one place, so that one only crosses at 0, but it touches and then goes back up at positive 4. There are, but 2 of them were both positive 4. It can't go down and then right back up at the same point. When you get 2 4s, that's telling you that is where it touches the x-axis and immediately goes right back up. When you have 2 of the same solution. Okay? If I would have had 2 zeros, then that would have told me it touched at 0 and went right back up at 0. Okay? There's a little bit nicer one. That one's not so tore up like the one I gave you. Okay, so let's do another one like this. Let's do a quartic here. I have f of x equals x to the 4th minus 18x squared plus 81, I believe it is, yes. Okay. They want you to find the zeros and sketch a graph of the function. Okay. And like I said, when we say sketch, we know on our assignments they're going to give you like 4 graphs and you're going to choose the right one. Okay, that's typically what we've been doing once we got outside of our quadratics and our linear functions. So what do I need to do to factor this? Because that's going to be the only way to do it. You can't use quadratics. It's not a quadratic. What multiplies the 81 adds to negative 18 in your... Okay, so I have x minus 9 and x minus 9. But since this is a 4 and a 2, this should be x squared and this should be x squared. Am I done factoring? No, because those are both what? Difference of 2 squares. So what does this factor to? And that factors to? Okay. So do I have 4 solutions here if I were to find the zeros? Yes, I do. However, I have 2 solutions 2 times, right? Yes. Okay, so my x is equal to what? Negative 3 and positive 3. And again, there's no reason to write those out multiple times. But since I do know that I have 2 negative 3's and 2 positive 3's, is it actually crossing the x-axis at those points? No, it's doing what? It's touching it and going right back up there. Okay? So, if I were to graph this, let me find a graph here. If I were to graph this, I would know that I definitely need a point at negative 3 and positive 3 on my x-axis. Because I know my graph goes or touches those 2 points, right? Mm-hmm. Okay. See if anybody can tell me this. What other point do I know for a fact it touches based on the original equation?
81.
81 where?
Y.
On the y-axis. Remember that last number, your c, is your y-intercept every single time. So, obviously I'm going to have to change the scale of my y-axis, right? So I'm going to change it to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I'm going to put a point up here at 81. Okay. Now, if I were to just give you those 3 points just like that and not tell you any information about it, I'm going to bet you're probably going to think it's a parabola. Okay, just because we've done so much of it. Okay, but is it logical for a function that is x to the fourth to be a parabola? Excuse me. No. What degree makes a parabola? Second degree. Degree of 2. Okay, quadratic. Hopefully by now you know a quartic, x to the fourth, is going to be like W or M shaped depending on whether it's positive or negative. If it's positive, what happens to the end behavior of a quartic function? It goes up. Okay, so what that tells me is that my graph must look something like that. That wasn't very well drawn, but it would look something like that, right? Okay. How do I know, other than the fact that I just told you, that if I have just -3 and +3, how do I know that it doesn't touch? Well, because if I were to do this and just assume that it goes below, based on the end behavior, I know it's got to come back up, right? How many intercepts would that have given me if that happened? 4. I have 2, so that wouldn't make any sense. Okay, so just pay close attention to that when you're selecting the graphs that go along with your factored function. Okay. So the only thing different here is that we're setting things equal to 0, really, right? Otherwise, it's the exact same thing we've been doing. Now, this next thing I'm going to show you with the rational root theorem is very different than everything we've been doing. We're going to use some synthetic division, so that would be a common thing. We will factor at some points, okay, but for the most part, this is going to be new. These problems that we're about to do are going to be the problems that you have like 1 on a test because they're that long. Okay, so we're going to set this up. We'll talk about the rational root theorem first. It's not super difficult. It's just time consuming. Okay, so what we're doing with the rational root theorem, I'm going to use factors or possible factors of a function to factor this, and I'll show you more in a second. But I'm going to use plus or minus P over Q. Okay, your P is the factors of, they say A sub 0. You guys are going to recognize it as just C, meaning it's where at in our function. The very, very end, right? Okay, in a quadratic, it would be the third spot. Okay, so I guess it's not technically always C. In a quadratic, it would be C. How should we word that instead? How about end coefficient? X to the 0. Do you guys understand that? It'd be your x to the 0 coefficient. Okay, so it's going to be factors of that number. In this previous problem we just did, that number would be 81. Okay, it's always going to be your n number, A sub 0. Okay, on the bottom is going to be the factors of your leading coefficient. Okay, and when I say factors, I mean like factors of 6 are 1, 2, 3, and 6, right? Okay. Okay, so we are going to use this idea, and we're going to have to list all the possible factors, and then we will go into synthetic division and figure out which ones work. Okay, so the example they give us, or the extra example I have in my book, is x cubed plus x squared minus 14x minus 24 equals 0. Okay. You won't have to do this on all problems, and luckily in your assignment for sure, they're going to tell you when to do this. Okay. The first thing I would try to do if I just randomly saw a cubic function where it has 4 things is do what to factor this? It has 4 things. Group it. Okay. If it has 4 things, we should group it. Okay. Well, if you try to group this, what can I take out of this? X squared. And I end up with x plus 1. What can I take out of this? Negative 2. And I end up with 7x plus 12. What's the problem? My groups of parentheses are different, right? Okay, so you can't factor this by grouping. If that happens, which, like I said, in your assignment, you're going to know because they're going to tell you to do it this way. Okay, but if that were to happen, I would know that I have to come and I have to use this other way that I'm about to show you. Okay? Because I can't use quadratic formula because it's a cubic. Right? If you couldn't factor it and it was a quadratic, I would probably just plug it into quadratic formula. Okay, but since it's not a quadratic, that's not possible. So we're going to set this up in synthetic division. So I'm going to have a 1, a negative 14, and a negative 24. Sorry, I'm getting ahead of myself. We're first going to list all our possible factors, and then we'll set it up in synthetic division. First, list all our possible factors. So I know that I'm going to have plus and minus versions of each fraction. Now on top is going to be all the factors of a sub 0, or x to the 0 power, which in this case would be, and you can just think of it as positive 24 because when we do the plus or minus, it's going to take care of that negative sign for you. Okay, but either way, 24, what are the factors starting at 1? 1, 2, 3, 4, 6, 8, 12, and 24. Okay? Okay, it's not going to let me spread those out. I'll just have to cram. Okay? And I know they're all going to be fractions. And I know they are all going to have a positive and a negative version. Okay, so I'm going to do plus or minus, 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 plus or minus. Okay, you're probably already seeing how this problem could get kind of long, right? Okay, you don't even know what we're doing yet. Okay, just the fact that we had to write out that many different possible factors is going to make the problem long. Okay? Factors of the leading coefficient. Well, what is the leading coefficient? 1. That's nice, right? 1, 1, 1, 1, 1, 1, 1, 1. If you have a number that's not 1, so let's say you had a 2, then you would have the factors of 1 and 2, correct? In which case, you would have to do all this again. But on the bottom, you'd have to put 2's. Now, notice 24 over 2, that's 12. Already did that. 12 over 2, that's 6. Already did that. 8 over 2 is 4. Did that. 6 over 2 is 3. Did that. 4 over 2 is 2. Did that. 2 over 2 is 1. Okay? But is it going to add some more? Definitely. Okay? And obviously if I went to a bigger number, maybe I went to 6, like I said. Now you're going to have 4 rows of this. Okay? So obviously the bigger your leading coefficient gets, the more difficult this is going to be, right? You don't have to do that today, so don't worry about that. We'll talk about that tomorrow. Okay? Currently the leading coefficient is 1. Your very last problem on what you can do tonight does have a 2. They're just throwing it at you to see if you're ready, could do it for the next step. Okay? So, anyways, we'll worry about that later. Now let's set this up in synthetic division. So I have a 1, 1, negative 14, negative 24. Okay, so I tried to factor it. It didn't factor. I listed all my possible factors. Now I am going to plug in until I find one of these numbers that is a factor. In synthetic division, how am I going to tell if it is or is not a factor?
The number is 0.
If your remainder is 0, right? Okay, so we are looking to plug something in and get a 0 here. Okay? I would start with your 1s because hopefully the 1s work, right? Because those are going to be the easiest. So I'm going to try a positive 1. This is 1. 1 times 1 is 1 plus 1 is 1 times 2 is negative 14 plus 2. Negative 12 times 1. Obviously not going to work, right? So what do? You start over. And you try negative 1. 1. I have negative 1. Luckily, synthetic division is a fairly quick process. 0. 0. Negative 14. Negative 1 times negative 14 is positive 14. Not going to work, right? So I try a different one. Okay, those are obviously both out as options. You want to try positive or negative 2? Positive? We want negative, I think, just from what I remember. Negative 2 times 1 is negative 2. 1 plus negative 2 is negative 1. Negative 2 times negative 1 is positive 2. Negative 14 plus 2 is negative 12. Negative 2 times negative 12 is positive 24. 0. Okay? If that wouldn't have worked, you'd have went to positive 2. If that wouldn't have worked, you just went to your 3s and you'd have kept going. They're not going to make you go all the way to like 8. Okay, you're going to find something before you get too far. Okay, they're not going to do that to you. So, what this means is that this negative 2 is a 0. So what would the factored or the parentheses look like if this was a 0? Would it be x minus 2 or x plus 2? It would be x plus 2. Okay. And what that leaves us is it leaves us this polynomial. Okay, everybody remember how we pull a polynomial out of that synthetic division? Mm-hmm. Damien, you with us? Yeah. Zach, you with us? Doing all right? Okay, this would be negative 12x to the 0, negative 1x to the first, 1x to the second. So then I have x squared minus x minus 12. Okay. For sure today, I'm going to tell you it's possible tomorrow that this won't happen. But once you do this one time, this is probably going to be factorable. Okay? Yes, Peyton?
So we're just not doing anything with 0 on the end?
Well, the 0 is your remainder. Remember, and there is no remainder. I mean, well, you could, but if you're putting 0 over something, it's just nothing, right?
Okay. Wait, but if it was a number?
Then it's not a factor anyway, so you shouldn't be using it.
Okay, but how would you, what do you put it over? You know what I'm saying?
In this case, it'd be x plus 2. Put it over your factor. Yeah. That would just be doing synthetic division straight. But we're probably not ever going to use that again because the whole reason we were doing synthetic division was to lead us into this stuff. Okay. So, is this fully factored yet? No. So let's finish factoring that. So I have x plus 2. What multiplies to negative 12 adds to negative 1? Negative 4 and what? 3. So I have x plus 3 and x minus 4. Is everything fully factored now?
Yes.
Okay. My zeros are -2, -3, and +4. Does that make sense that there are 3 zeros in a cubic function? Yes. So, does this graph cross the x-axis 3 times, or does it touch at one point and go back up? It crosses all 3 times.
Is that the one that looks like?
Yep.
Okay.
Something like that. Okay. Okay. So, I'm going to give you the rest of the class to work. I'm not going to have you solve an extra one of those just for time. You can finish, and I need you to finish through problem number, what did I tell them? 25. But you can go through 31. I will turn it in tomorrow and make sure you're through 25 though.
25 up to 30.
What?
Yeah?
You need through 25. You are able to do through 31. I'm going to tell you, you're going to want to do as many as possible because tomorrow's is going to be longer. Not number-wise, but it'll just take more time.